Good day to you, my viewers from any part of the world. You are privileged to be seeing this video. I am Mr. Femi and I want to walk you through basic map reading and interpretation, which constitutes an aspect of practical geography. And today what we want to be looking at is scales of a map and also look at scale conversion. In our last episode on this same subject, we have been able to look at basic essentials of a map. We've been able to look at the concept of distance, direction, and bearing. So today we want to look at scales of a map and also look at scale conversion. Okay, so by way of recapitulation, I want to recap what we said in the last class. In the last episode, we were able to define what is geography. We look at the meaning of map reading. We also look at what exactly is bearing. We look at the cardinal points. We look at the 4 cardinal points. We look at the 8 cardinal point and the 16 cardinal point. And of course, the top of the cardinal represents the north degree. The north direction. On the north direction, you have your 0 degree as well as 360 degree. So to your right, we move in a clockwise direction. So to your right, you have the northeast, and the bearing of northeast, the bearing of northeast is 22.5 degree northeast, and then next one is 45 degree northeast. Then you move right again, you see 67.5 degree east northeast. Then of course after that you have your 90 degree east, and it moves round like that until you come back to the north again, which is your 360 degree. So we also look at professional careers that find their relevance, that find their background actually in geography. We look at geology, geophysics, pilots, economics, ecology, GIS, quantity surveying, and estate management, and many others like that. So I said something when we were talking about distance, and I said something that to determine the direction of a bearing of a place or of a feature, always put your 4 cardinal points on the reference. For example, the reference point is where the question says from, and the place or feature whose direction or bearing you are to determine is where the question says of. Example I gave in that class, I said if they ask you what is the direction of this from this, the direction of this from this, when they say from, that is where you put your cardinal point. I repeat it again. I said where they say from, that is the place you put your cardinal point. All right. Okay, so let's go to today's lecture. So we have looked at the basic essentials of map. We have all of these things. So I still want to recapitulate what I said in the previous class, that a map is a portion of the feature of the earth surface drawn on a plane surface such as paper using a appropriate scale. So we look at the basic essentials of a map. What are the things that you can see and you can say of a truth, this is a very good map? Number 1 is the title. Number 2 is the key. The key is also called legend. And then the number 3 is the margin. The margin is also called the border. Then number 4 is the north direction. North direction provides you with orientation, how to orientate your map, how to turn your map. Okay. Then the last one is the scale. So now I said that there are factors that determine the amount of details that can be represented on a map. Now, let me say this, that the map, the features on the earth surface that you want to represent on a paper is too voluminous. There are many features on the earth surface. You can't capture everything on a single piece of paper. However, the amount of information that you are going to represent on a map depends on several factors. And some of those factors is the scale that you are using. Number 2 is the projection. Number 3 is the conventional science. Number 4 is the method. And then number 5 is the skill of the cartographer. Cartographer is the person that produces map. Okay? So, now this is a typical map. This is the map of Ayala district, and these are the essential features. So, when you see the map of Ayala district here, you can see the title of this map is saying Ayala district. That is the title. Then you have this arrow here. It shows you the north out. That is the north direction. That is the orientation. I cannot carry this map now, for instance, and turn it upside down and start interpreting it. It will be very wrong, because the arrow has told me from this that I should position my map in a straight way. Then this line is called the border line. This line is called the border line. It gives you the boundary of the map. Then we have the scale here, and then we have the key. The key is like the key opens the map for interpretation. As you have your key to your house, so also this key, the key of a map, opens up the map for interpretation. Without the key, you will not understand what this sign means. For example, without the key, you will not understand what this sign means. Key is a legend that interprets the sign, the conventional signs that are used on the map. Okay, so when you see this sign like this area of the map is telling you that this is an oil palm plantation. When you see something like this, it's telling you from this key that this represents a scattered vegetation. Okay, so and etc. like that. So we have key number 1, we have scale number 2, we have border number 3, we have north arrow number 4, and then we have title number 5. This represents the basic essentials features of a map. Okay, now this is a summary, and I believe that you understand what I've said so far. So let us test our knowledge. What do you understand so far from what I've said? What are the basic essentials of a map? I want you to comment that in the comment section. I want you to comment that on the comment section. What are the basic essentials of a map? Also, I want you to list at least 2 factors that determine the size of a map. Or alternatively, you can send your answer to practicalgeographylectures@gmail.com. practicalgeographylectures@gmail.com. Thank you very much. Now, we want to look at the scale of a map. And at the end of this particular slide, you should be able to explain the meaning of a scale and also identify and differentiate the different types of scale. What determines the choice of a scale of a map? What is scale? What is the formula for scale? And then what are the expression or representation of scale? How can we express a scale? Okay, now let me start from my right here. What is a scale? The scale of a map is the relationship between the distance on a map and the actual ground distance. You know, the distance on the ground is in kilometers, but you can't put kilometers on the paper. So, scale helps us to understand the relationship between the distance we see on the map and the actual ground distance. Alright, so what is the formula? Scale can be deduced as scale to be equal to distance on map over actual distance on Earth's surface. Actual ground distance. So actual distance on ground, distance on the map over actual ground distance. So what are the factors that determine the choice of a scale of a map? Number one, the size of the area you want to map. If you want to map only your room, you know the kind of scale to use. If you are mapping the whole continent of Africa, the whole continent of Europe, the whole continent of Asia, it's a very big area of land. So that one also determines the kind of scale to use. Then number two, the amount of details and features to represent. Are you capturing everything on the Earth surface? Or you just want to capture only areas where we have oil production, crude oil production? Or you just want to capture only area we have earthquake or earthquake prone areas that are prone to earthquake event? So what are the features you want to represent on that map? So this determines the size of the scale to use. Number three, the size of the paper. If you are having a paper as big as your sitting room, then you can decide to use a very small scale. And if you are using an A4 paper, you can decide to use a very big scale. I'm going to explain what we mean by very big scale and a very small scale. If you have a very small paper, you will use a very big scale. If you have a very big paper, you will use a very small scale. A very small scale. Thank you. So, what are the expression or representation of a scale? There are three basic ways to represent, to express a scale. There are three basic ways to express a scale. Number one is the statement scale. You can express your scale in form of statement. For example, you can say 1 centimeter to represent 2 kilometers. It's as simple as that, just in a statement scale. Then number two, we have linear scale or graphic scale or bar scale. Now in this one, you have a line, and on each of those lines, you calibrate the line and you put the kilometer equivalent on that line you calibrate. So you use your ruler to determine the centimeter and you equate it to the kilometer on that line. Then number three, we have representative fraction. So representative fraction, we have examples of representative fraction which we are going to see in the next slide. Just let's go. Okay, so linear scale. This type shows scale in graphic format. The actual length of the bar scale on the map scale, when measured with ruler, indicates the actual ground length in real world units. For example, let me just give you this example. You can pick your ruler when you have a map, and in that map they give you this kind of scale. What you will do is to get a ruler, measure from 0 to 2. How many centimeter? If it is 1 centimeter, it means that 1 centimeter from here is equal to 2 kilometers. It's as simple as that. Because the difference between 2 and 0 is 2. The difference between 4 and 2 is 2. The difference between 6 and 4 is 2. And you see that it is constant throughout the entire scale. Here is another one. So, linear scale can be divided into two subscales. We have secondary division and we have the primary division. So in the secondary division, you have this part. This secondary division is always to the left and the primary division is always to the right. So you have it in this way. The same procedure goes for the two. Example. The following scales are in representative fraction. What does each of them stand for? Look at this example. The first one is 1:100,000. The second one is 1:50,000. The third one is 1:200,000. The fourth one is 1:400,000. And the fifth one is 1:25,000. I put a hint here for you, and I said 100,000 centimeter is equal to 1 kilometer. Now look at this. This is the solution. 1:100,000 stands for 1 centimeter on the map represent 100,000 centimeter on the ground. So when you see 1:100,000, it means that 1 centimeter on the map, any 1 centimeter you measure on the map, it represents 100,000 centimeter on the ground. And because 100 centimeter is equal to 1 kilometer, it means that every 1 centimeter you measure on the map represents 1 kilometer on actual ground distance. Okay, so we have the second one says 1:50,000. The same way, 50,000 is the half of 100,000. So if 100,000 is 1 kilometer, automatically you know that 50,000 will be half kilometer. All right. So which means that 1 centimeter on the map represents 50,000 centimeter on the ground. It also means 1 centimeter on the map represents half kilometer on the ground. That's a typographical error here. Okay, so number 3, 1:200,000 means 1 centimeter on the map represents 200,000 on the ground. It also means 1 centimeter on the map represents 2 kilometers. You remember that 100,000 centimeter is equal to 1 kilometer. So 200,000 centimeter will be equal to 2 kilometers on the ground. Okay. And it continues like that. All right. Now, there is one technicality. There is one question here that looks technical. Look at this number 5. It says 1 centimeter, 1:25,000. 1:25,000. What does it mean? Now, 25,000 is 1/4 of a kilometer, because 25,000 is 1/4 of 100,000. Now, look at this. I said this also means that 1 centimeter on the map represents 1/4 kilometer on the ground. Now, if you do something like this, this is 25,000. Let's divide it by 100,000. It will give us 1/4 of a kilometer. Now, if you cross multiply, what we are saying is that 1 centimeter is equal to 1/4 of a kilometer. But it is not easy to understand this expression for a layman. So what we do is to cross multiply, and we say that 4 times 1, 4. 1 times 1 give us 1. So it is easier, it is understandable to say 4 centimeter on the map represent 1 kilometer on the ground. Meaning that if you measure 4 centimeter on the map, that 4 centimeter represent 1 kilometer. And if you measure 1 centimeter on the map, it represents 1/4 of a kilometer on the map. So let's summarize what we've said so far. I said that the scale of a map is a relationship between the distance on the map and the true or actual ground distance. And I said that the factors that determines the choice of scale to use, there are 3. Number 1 is the size of the area you want to map. Number 2 is the amount of the details you want to capture in the map. And then number 3 is the size of the paper available. Now, and I said there are 3 ways of expressing our scale. The first one is a statement scale. The second one is a linear or graphic format scale. Then number 3 is the representative fraction. And we have the example here. So there is a mail here where you can submit your questions. We have questions, and the email is practicalgeographylectures@gmail.com. Don't forget it has X. practicalgeographylectures@gmail.com. So what do you understand so far? I want you to test your understanding. What is a scale? In what three ways can scale be expressed? Send your answer to practicalgeographylectures@gmail.com. So now this is the final slide. We want to look at scale conversion. And at the end of this series, you should be able to convert statement scale to representative fraction and vice versa. You should be able to convert linear scale to statement scale and vice versa. And you should be able to convert representative fraction to linear scale and vice versa. So, how do you convert a statement scale to representative fraction? How do you convert scale in statement form to representative fraction? First, you write out the statement scale clearly. Then, secondly, you express the two parts of the scale in the same unit, most times in centimeters. Don't forget that 1 kilometer is equal to 100,000 centimeters. Okay? So then write the scale as a fraction. Make the distance on the map to be the numerator and the distance on the ground as denominator. Then divide out the fraction until numerator equals to 1. Look at this example. This example 1. You are required to convert the following statement scale to a scale in representative fraction. Given a map with scale 1 centimeter to 1 kilometer, you are given a scale of a map to be 1 centimeter representing 2 kilometers. And secondly, you are given a map and the scale of that map says 1 centimeter represents 4 kilometers. How do you solve this one? How do you convert it to representative fraction? Let's see. So the first thing to do is to write out the statement scale clearly. You write it out as 1 centimeter to 2 kilometers. Okay? Now you understand that 1 kilometer is 100,000 centimeters. Therefore, it means that 2 kilometers will be equals to 200,000 centimeters. So thus, it means that your 1 centimeter to 2 kilometers in representative fraction becomes 1:200,000, like that. And that is the answer. 1:200,000. Don't forget, this one is already in centimeter. It is this 2 kilometers you need to convert to centimeter. And 2 kilometers is the same thing as 200,000 centimeters. So it means that in representative fraction, your scale will be 1:200,000. This is the second part. You are given 1 to 4 kilometers. So you write out the scale. You write it out clearly. Then you now express the two parts of the scale in the same unit. This one is already in centimeter. This 4 kilometers is what you need to convert to centimeter. And 4 kilometers is the same thing as 400,000 centimeters. So in representative fraction, the new scale will be 1:400,000. 1:400,000. And that's what you see here as your final answer. All right. What do you understand in this lesson today? I want you to test yourself. This is end of session assessment. Convert 2 centimeter to 3 kilometer scale to a scale in representative fraction. Convert 2 centimeter to 3 kilometer scale. Convert 2 centimeter to 3 kilometer scale to a scale in representative fraction. Send your answer to practicalgeographylectures@gmail.com. Alright, conversion from representative fraction to statement scale. Conversion from representative fraction to statement scale. How do you do that? The first thing to do is to write out the representative fraction scale, write it out in the same unit. Then divide the ground distance in centimeter by 100,000 to convert it to kilometer. Note that the ground distance is usually the highest value in the ratio, in the fraction. So example, I know by the time I do this example you will understand. Example 2, you are provided with topographical maps whose scale are number 1:50,000. The second one is 1:200,000. You have to convert it to statement scale. How do you do that? Let's see. So you are given 1:50,000. So what do? In this case, you write out that 50,000, you divide it by 100,000. You want to convert it to kilometer. So you divide it by 100,000. So you say 1 centimeter to represent 50,000 centimeter. So the scale will be equals to map distance over, ground distance over the conversion factor. So the conversion factor is 100,000 centimeter. So you say 50,000 divided by 100,000 will give you 1/2. So the answer in statement scale means that 1 centimeter it means that 1 centimeter represents half kilometer on the ground. And that is what you have here. 1 centimeter on the map represents half kilometer on the ground surface. Then the second one says 1:200,000. Don't forget that 200,000 is the same thing as 2 kilometers. So you just say 200,000 divided by 100,000. If you cancel the zeros, you will be left with 2. So the answer is simple. It means that 1 centimeter on the map represents 2 kilometers on the ground. Alright. What do you understand so far? I want you to test yourself. Convert this scale to a scale in statement. 1:300,000. What is the answer in statement scale? Send your answer to practicalgeographylectures@gmail.com. Now, this is the conversion from linear scale to statement scale. Conversion from linear scale to statement scale. How do you do that? So you first use ruler to measure the length of only 1 unit. Just carry your ruler, measure from here to here. If it is 2, write 2 centimeters because it is 2 centimeters on your ruler, write 2 centimeters. Then, because from here to here is 1 kilometer, you just say 1 centimeter represents 2 centimeters represent 1 kilometer. It's as simple as that. Now, look at this. If the scale below is a linear scale, convert it to a statement scale. The scale below is a linear scale, convert it to linear scale. If you measure the distance from 0 to 1 kilometer, you will discover it is just 2 centimeters. Just put your ruler here to this place, you discover it's 2 centimeters. And what does that mean? It means that 2 centimeters on your map distance. It means that in a statement scale, it means that 2 centimeters represent 1 kilometer. It's as simple as that. Or if you want to just simplify it further, you can say 1 centimeter represents half kilometer. Okay. So This is how far we will see for today. I want to appreciate you. Thank you for your attention and your participation. If you have any question, don't hesitate to send your question to practical geography lectures at gmail.com. Thank you for being part of the class today. We will see you in our next class. And till that time, I encourage you to stay motivated, be optimistic, and that exam you are about to write, you will make an excellent grade. Thank you very much once again. God bless you.